Have you ever been walking through a city, looked up, and seen a forest, like a full-on forest growing on the side of a building, hundreds of feet in the air? It's really happening, and today we're going to pull back the curtain and look at the incredible blueprint that makes these gardens in the sky actually possible. But let's start with the most obvious question, right? Why? Why are we doing this? Why are our buildings suddenly growing forests? Is this all just for looks, some kind of fancy design trend? Or is there something much, much bigger going on here? Okay, let's just dive right in with a perfect example, the Trudeau vertical forest. Now, look at that. This is so much more than a few potted plants on a balcony. We're talking about a living, breathing ecosystem built into a social housing project. This thing is a serious feat of engineering, and we're about to break down exactly how it works. To really get our heads around these vertical forests, you have to think way beyond the simple green roof that you might have seen before. We're talking about a huge leap, a jump from flat, two-dimensional green carpets to these complex, three-dimensional spaces. This visual really breaks it down nicely. So, on the left, you've got your standard 2D green surfaces, like a classic green roof. They're great, but they're pretty limited. But on the right, well, that's where we get into 3D spaces. Architects have a cool name for them: green pockets. Think rooftop gardens, balconies overflowing with life, and indoor atriums. They just open up a whole new world of possibility. So yeah, let's get that term locked in. Green pockets. These are those rich 3D green spaces we're talking about. They can be outdoors, indoors, or kind of a mix of both. And the key thing here is they can support a way bigger variety of plants, including full-size trees. And that, my friends, is a total game changer for cities. The whole philosophy driving this movement has a name too. It's called biophilic design, and it's based on this really simple but powerful idea. As people, we have this deep, primal need to connect with nature. It's just baked into our DNA. So these green pockets are architecture's answer to that craving. It's all about making our lives better by weaving nature back into the places we live and work. But here's the thing. Making that happen is not easy. At all. It takes a serious engineering blueprint. You're basically designing and building a custom, high-tech life support system for every single tree and shrub on the building. It all comes down to these core layers. Honestly, the easiest way to think about it is like a super high-tech lasagna for a tree. You've got to start with a really tough, waterproofing membrane, obviously to protect the building. Then you add a drainage layer so the roots don't drown. After that, a filtration layer to stop everything from getting clogged up. And finally, on top, you have the substrate. That's the specially engineered soil that's going to keep the plant alive. And here is what that lasagna looks like in real life. This is a cutaway view of a planter from that Trudeau tower we saw. You can see all those layers working together perfectly. The special soil, the filter, the water storage. It is literally a self-contained ecosystem, engineered with incredible precision to keep a huge tree happy, hundreds of feet up in the sky. Now, get ready for this number, 'cause it's wild. 865 kilograms per square meter. That's the weight of the special soil needed for just one 10-meter-tall tree. To put that in perspective, it's like parking a small car on every single balcony that has a tree. The structural load is just immense. So, okay, let's say you've solved the massive engineering problem. You're not done yet. Not even close. Now, you have to face the next giant challenge, the biology. You can't just stick any old plant up there and hope for the best. Picking the right plants, the living palette, is a whole science in itself. Botanists and designers have to juggle all of these factors. It is so much more than just what looks pretty. First, does the plant even work in the local climate? But then, even more important, can it handle the microclimate of one specific balcony? The 15th floor on the windy side of the building is a totally different world from the 5th floor on the shady side. It's a huge, complicated puzzle. And here's a perfect example of what I mean. Just look at these two completely different worlds. On one side, you've got this lush, sheltered, subtropical paradise inside the Hotel Jakarta. It's warm, humid, totally protected. And on the other side, a balcony on the Trudeau Tower, getting blasted by wind and sun 19 stories up. The plants you choose for each of these green pockets have to be completely different if they're going to have any chance of survival. So you've built the structure, you've picked the plants, the job is done, right? Not even close. Now the real work begins. The long-term commitment of keeping this garden in the sky alive and healthy. This is the stuff that nobody sees, but it is absolutely crucial. We're talking about automated irrigation systems that use sensors to deliver water and nutrients. We're talking about regular pruning, which is sometimes done by specialized gardeners rappelling down the side of the building. No joke. And of course, constant checkups on the waterproofing and all the structural anchors holding this whole thing together. It is a massive ongoing effort, which, brings us right back to that first big question. Why? Why on earth go through all of this trouble and all of this expense? Well, because the payoff, what we call the biophilic payoff, is just huge. It's huge for the planet, and it's huge for us. The truth is, these projects do so much more than just look nice. They are actual solutions to some of our biggest urban problems. They create new habitats for birds and insects, boosting biodiversity right in the middle of a concrete jungle. They actually cool our cities down, fighting that urban heat island effect. They help insulate the building, which saves energy, and maybe most important of all, they create these beautiful, calming spaces that have been shown to actually improve our mental and physical health. Let's look at a few quick examples of this payoff in action. At the Erasmus Medical Center, this rooftop garden isn't just decoration, it's literally a tool for healing. It was designed specifically to be a therapeutic, healing garden for patients and a quiet place for the hospital staff to decompress. It's a perfect example of the human benefit of biophilic design. And then there's the Trudeau vertical forest again. This project is so important because it proves this idea isn't just for fancy luxury condos. This is social housing. It provides affordable homes for people, and those homes are wrapped in a living forest of 5,200 plants. It's basically democratizing the right to live with nature. And finally, at Hotel Jakarta, they flipped the idea and turned the green pocket inward. They've built an entire subtropical world inside the building. It's a total oasis in the middle of the city, showing how this kind of architecture can create brand new restorative environments right where we are. So when you put it all together, the philosophy, the incredible engineering, the complex biology, and the amazing benefits, it really leaves you with one final, very exciting question. If we can already engineer entire forests on the sides of skyscrapers, what else is possible? What's next for the future of our cities?